Hi, good morning. My name is Mudawat Lakshman and I'm from Computer Science and Engineering Department. Today I'm going to discuss about the history of software engineering from the subject object oriented software engineering. So now we are going to it's an introduction to software engineering. Software engineering is a discipline dedicated to designing, developing, and maintaining software systems. It emerged in response to the growing complexity of software projects. The field combines principles from computer science, engineering, and project management. Software engineering is a systematic, disciplined approach to the design, development, testing, and maintenance of software systems. It emerged as a separate discipline due to the increasing size and complexity of software projects. Unlike simple programming, software engineering combines computer concept with engineering principles and project management practices. The goal is to produce reliable, efficient, maintainable, and high quality software that meets user requirements. And early computing and programming. Early computers were programmed using machine language and assembly language. Programming was often done by individual scientists and engineers. Software was viewed as byproduct of hardware development rather than a distinct discipline. In the earlier days of computing, software development was very primitive. Programs were written directly in a machine language or assembly language, which was difficult, error prone, and time consuming. Programming was usually performed by individual scientists or engineers, and there were no standard development processes. Software was treated as a secondary component of hardware, and a very little attention was given to documentation and maintenance or reusability. And next, software crisis of 1960s. The projects ran over budget and behind schedule. Software was unreliable and hard to maintain, highlighted the need for structured development practices. The software crisis of 1960s arose when rapidly growing computers systems became too complex to manage. Projects often ran late, exceeds budgets, and produced unreliable results. Developers struggled with poor tools, inadequate methodologies, and rising maintenance costs. Highlights the urgent need for structured discipline approaches to software engineering. So the software crisis in 1960s highlighted serious problem in software development. Many projects failed due to cost overruns, missed deadlines, and unreliable software. Systems became too complex to manage using ad hoc coding practices. Developers faced poor tools, lack of proper methodologies, and high maintenance costs. This crisis clearly showed the need for structured, disciplined approach to software development and marked a turning point in the evolution of software engineering. So next, the birth of software engineering 1968. The term software engineering was coined at the NATO Software Engineering Conference in 1968. The conference addressed the software crisis resulting from project failures and delays. It marked the beginning of formal efforts to improve software development practices. The term software engineering was formally introduced at the NATO Software Engineering Conference in 1968. The conference focused on addressing the software crisis and improving development practices. It emphasizes the need for engineering-based methods, documentation, and systematic project management. This event is widely considered the birth of software engineering as former discipline. Next, we move to the structured programming, that is from 1970. The structured programming promoted the use of control structure like loops and conditions for clarity. It aimed to improve code reliability, reduces errors. Languages like Pascal and C became popular tools for implementing structured programming. Well, structured programming emerged in 1970s to improve code clarity and reliability. It promoted the use of well-defined control structures such as sequence, selection, and iteration instead of unstructured jumps like goto. This approach made program easier to read, debug, and maintain. Programming languages such as Pascal and C supported structured programming and widely adopted in software development. Next, it is the time of object-oriented programming. Encapsulation, inheritance, and polymorphisms are introduced. Languages like C++ and Smalltalk emerged, promoted code reuse and modularity. Object-oriented programming introduced powerful concepts such as encapsulation, inheritance, and polymorphism. Software systems for modeling using objects that represent real world entities. Languages like C++ and Smalltalk become popular during this period. Object oriented programming improved modularity, reusability, and maintainability, making it easier to manage large complex software systems. Next, it is agile movement. So, shift from waterfall to iterative development. Agile Manifesto introduced in 2001, and it emphasizes on collaboration, flexibility, and customer feedback. That is, the agile movement emerged as a response to rigid development models like waterfall. Agile methodologies emphasizes iterative development, customer collaboration, and adaptability to change. The Agile Manifesto, published in 2001, defined core values and principles for agile development. Practices such as Scrum and extreme programming gained popularity, especially for projects with rapidly changing requirements. And next, the software tools and a case. That is computer aided software engineering. That is, case tools supported various stages of software development from design to testing. They aim to improve productivity and standardization. The tool facilitated model-driven development and automated code. Case computer-aided software engineering tools were introduced to support various stages of a software development in lifecycle. These tools helped with designing, modeling, code generation, testing, and documentation. Case tools aim to improve productivity, standardization, and quality. They played an important role in model-driven development and automation. Next, it's open source movement and web development. So, the open source movement and revolutionized software development by promoting collaboration and transparency. Projects like Linux and GNU demonstrated the power of community driven development. Tools such as Git and GitHub further enhanced global collaboration. At the same time, the rise of internet in 1990s led to rapid growth in web technologies like HTML, CSS, and JavaScript, enabling dynamic and interactive web applications. Next, it goes for modern practices. That is DevOps integration, development, and operation. CI/CD pipelines automate testing and deployment. Cloud native development enables scalability. Modern software engineering practices focus on speed, automation, and scalability. DevOps integration, development, and operations to improve collaboration and delivery speed. Continuous integration and continuous deployment CI/CD. That pipelines automate testing and deployment processing. Cloud native development allows application to scale efficiently using cloud platforms and microservices architecture. Next, that is software quality and testing. Emphasis on rigorous testing, debugging, or quality assurance technologies grew. Technologies like unit testing, integration testing, and formal verification were developed. Quality standards like ISO 9001 and IEEE standards became integral to software projects. As a software system becomes critical to society, emphasis on quality and testing increased. Various testing techniques such as unit testing, integration testing, system testing, and regression testing were developed. Quality assurance practices ensured reliability and correctness. International standards such as ISO 9001, IEEE guidelines helped establish best practices for software quality. And next, the software engineering education and professionalization. Software engineering became a professional discipline with a formal degree programs and certifications. Organizations such as IEEE and ACM established standards, codes of ethics, and best practices. Continuous learning and specialization become essential as technologies evolved. Professionalization improved accountability, quality, and ethical responsibility in software development. What are the advantages of software evolution? That is, in technical, the evolution of software engineering has led to improved reliability, maintainability, and scalability of software systems. Modern methodologies reduce development risks and costs. Reusable components and framework accelerate development. Overall, software evolution has enabled the creation of complex systems that support modern society. What are the modern challenges in software engineering? Despite advancements, software engineering faces many challenges today. This includes managing large-scale distributed systems, ensuring security and privacy, handling rapid technologies changes, and addressing ethical concerns. Balancing speed with quality remains as a critical issue. Developers must continuously adapt to new tools and methodologies. What are the summary of key milestones? Software engineering has evolved through multiple stages, from early programming practices to structured programming, object-oriented design, agile methodologies, and DevOps. Each phase addressed specific problems and contributed to shaping the discipline. This evolution reflects the growing complexity and importance of software in modern life. What are the future trends? The future trend in software engineering includes AI driven development and automated testing, quantum software engineering, and redefined computational possibilities. Low code and no code platforms aim to simplify development and make software creation more accessible. These trends indicate a shift towards greater automation and intelligence in software systems. Now we move to the conclusion of these slides. Software engineering has evolved from simple coding activities to mature a disciplined profession. This evolution reflects the increasing demand for reliable, ethical, and high quality software. Modern challenges highlight the need for innovation, adaptability, and responsibility. The future of software engineering will be continue to shape technological progress and social development. The references of this slide and this topic is this presentation is supported by standard references such as IEEE journals, ACM Digital Library, SWE BOK, and classical texts like the Mythical Man Month. These resources provide theoretical foundation and practical insights into software engineering. Thank you.